Hello friends, welcome back. In my previous videos, we were discussing about tractor weight transfer, weight distribution and stability. We have already completed tractor weight distribution in a static as well as dynamic condition, and stability we were discussing in my last video, and there we have completed everything about longitudinal stability. In this video I will talk about lateral stability. Okay, so this is me, and moving ahead. So what will happen in case of lateral stability? The tractor will overturn either about this axis joining front left wheel and rear left wheel, or about this axis. Okay, so why this is happening? So suppose this is centered and tractor is going to take a turn about this center. Radius of this is r. Okay, this is the CG location of tractor, and weight will act in downward direction. So guys, this is the top view. Okay, I hope you understand what top view is. Okay, so you are watching this tractor, you are in a helicopter, sitting in the helicopter, and your helicopter is flying just above this tractor, and you are watching this tractor from your helicopter window. So that will be your top view. So this is the top view of the tractor. Okay, so this tractor is going to take a turn. This is the wheelbase L, and there are two things guys, one is wheelbase and one is wheel thread. So I hope you know the term. If you don't know, then I will explain. The wheelbase is the distance between front wheel center and rear wheel center, and at the same time wheel thread is the distance between this rear left wheel center and rear right wheel center. So this horizontal distance is wheel thread of rear wheel. This is the wheel thread of front wheel. Okay, so what will happen? So assume that this tractor is moving in forward direction and u is the forward velocity. So and this tractor is going to take a turn. So we are assuming that the forward speed u of the tractor is gradually increasing. Okay, and when it is getting increased, the center of gravity will travel towards this center of this circle whose radius is r. So actually this tractor is going to take a turn. Okay, so in this case, if this tractor is going to take a turn, so what will happen? This weight acting downward, and the centrifugal force will act on the tractor in opposite direction. Okay guys, and at the same time you just imagine the condition. You are at a high speed and you are trying to take a turn. Okay, so ground will try to push you, okay, in opposite direction. So basically these two tires, in case of tractor or for that matter for any automobile, are in contact with ground. So the lateral tire forces which are acting on the ground, so they are also increasing. Okay, now what will happen? So these all forces will create a moment. Okay, moment about what? Moment about center of gravity of the tractor. And due to that, due to this moment, what will happen? Your tires, your right front tire and right rear tire will lift up, or will try to lift up from the ground surface. And if it completely lifts off from the ground, then your tractor will take lateral overturn. Okay, so what is happening actually in this case is your tractor is moving forward with you, and you are going to take a turn. So this is your center of gravity location. So this is the XCG, which is basically the location of horizontal location of CG from the rear axle center. As usual, this weight is acting downward, that is below this surface, below the plane. Okay, then this is the moment arm which I am talking about, moment. So this is the moment arm A. This is the plane about which your tractor is going to take a turn. Okay, this is the centrifugal force which is acting at the CG, and which will try to rotate your tractor, or try to lift up the tires off the ground, and your weight will try to put your tires on the ground. Okay, so these two will act in opposite directions. Okay guys, so now, and this is the angle which this centrifugal force is making with this component, okay, vector horizontal component. Okay guys, this angle is gamma. So all the terms are explained in this table. So basically G is the acceleration of gravity, gamma is the angle between this force mv square by r, which is the centrifugal force, and the plane, this tipping plane. Okay, so you can write the gamma as in terms of tan theta. So this will be tan inverse y1 by L. So what is y1? That I will explain, don't worry. And L is the wheelbase, L is the moment arm of the tractor, and U is the forward speed. Okay guys, so moving ahead. So you have already seen this photograph, and now to make it simpler, as I have already told you, this weight and centrifugal force will try to create a moment. Okay, so what will happen? Now we are assuming that this right front tire and rear tire have just lost the contact with the ground when your forward speed u has attained a critical value, which we call us, which is the critical speed at which your tire will lift the ground. Okay, so what will happen now? So tractor is now on the verge of overturning about the axis connecting the ground contact point on the left and front tire. Okay, so your tractor is going to make a turn about this axis. Okay guys, so this is the simple diagram of this. This is the ground surface. This is your tractor center of gravity. So your weight is acting downward. This ZCG is the vertical location of center of gravity from the ground. Okay, so if this is WT, so this is the top view. So if you see the back view or side view, then you will find this ZCG, and then your MV square by R. As I told you, MV square by R is acting in this direction, so this gamma is the angle of this moment. So the component of this MV square by R along this direction will be MV square by R cos gamma. Okay guys, I hope you understand this vector, and this is a vector in this direction, and this is the angle which vector is making with horizontal. So this component will be cos gamma. So this thing will be MV square by R into cos gamma. Okay guys, so what will happen? This MV square by R, MU square by R cos gamma will create a moment about this D point. So this vertical distance is ZCG. So MV square by R cos gamma into ZCG, and then this W will try to keep your tractor on the ground. So this WT into A will try to balance this WT into A. Guys, this WT into A will try to balance this MU square by R cos gamma into ZCG. Okay, just try to imagine this. Okay guys, so finally what will happen? From here you can find out your critical speed US at which your this tractor is going to make a overturn. Okay, I know that you all guys is knowing this equation, but I have deliberately tried to explain you the concept behind this US, how this US is coming. You all might have remembered this, that US is equal to under square of GAR by ZG cos gamma, but this is how it is coming. Okay guys, if you still have doubt, then ask me in the comment section. Okay, so basically what is happening, this WT, if you take a moment about point D is here. Okay, so this WT will try to rotate it about in this direction. Okay, in this direction, clockwise direction. Okay, and the perpendicular distance is A. So WT into A will try to rotate the system in this direction. So basically it will try to keep your tire on the ground, and this MV square by R into cos gamma into ZCG, this will try to rotate the system in opposite direction, in clockwise direction. So when we balance these two things, we can find out what is the critical speed at which this tractor is going to make a overturn, lateral overturn. If this forward speed is less than US, then the operation is stable. Okay, if it is more than US, then it is going to be unstable. Okay guys, moving ahead. So you already know this US. Now what will be gamma? So I have already told you that this tan inverse y1 by L. So what is y1? So I have told you in the beginning that something about thread. So guys, this is the rear wheel thread. Okay, this distance, and then this is the front wheel thread. Okay guys, so you see this is the half of rear wheel thread from here to here, and this is the half of front wheel thread. So the difference between these two will be y1. So it is a common sense. So y1 is rear wheel thread minus front wheel thread by 2. Now just imagine what will happen. This is a two-wheel drive condition. Okay guys, now just imagine what will happen in case of four-wheel drive. So in case of four-wheel drive, all four tires are of same size, so there won't be any difference between front wheel thread and rear wheel thread. So in case of four-wheel drive tractor, the rear wheel thread and front wheel thread both are going to be equal. So in that case, this your gamma, cos gamma, which is coming over here, this cos gamma, this will be 1. So in that case, your critical speed will be under root GAR by ZG only. This cos gamma component will be 1. Why 1? Because these two are equal. Okay, so this y1 is going to be 0 and cos 0 will be. So I think you are smart enough to derive this. Then there are some other things are there, like normally in your question they will give these values, but if they won't give, then you can derive these values. So you know now this triangle. Okay, this triangle you know already. You have seen, I have explained this triangle to you. This is the moment arm. Okay, this is wheel thread. This is YCG, horizontal location of this is XCG, which is horizontal location of CG. YCG is vertical location, or ZCG is vertical location. This L is wheel base. Y1 is wheel thread by 2. I have already told you this one. So you can derive this on the basis of simple geometry, this A. Then second thing will be your E. Okay, so this is your E. Okay, so again this is also simple geometry, and in this formula this B is coming. So what is B? B also you can derive L square plus Y1 square. This is your L and this is your Y1. So your B is nothing but this length. So B will be simple triangle equation, L square plus Y1 square. Okay guys, so these three formulas are also important if they won't give these formulas in exam, but normally I think and I believe that they will give these three values is not required. Only you need these E and B to derive A. So they will directly give the value of A, the moment arm, normally in examination in questions. So if you know A, then you directly can calculate this US. Okay guys, so I know that you guys are aware about this equation, but this is how this equation is coming. Okay, and this is the concept behind this. So guys, I have completed lateral stability as well as longitudinal stability. Okay, so weight transfer, everything we have completed. Weight distribution we have completed. Stability thing we have seen and we have discussed enough, both longitudinal as well as lateral stability. Why the tractor operation will be unstable, that we have seen. So guys, these are extremely important. Now I am going to make videos on determination of tractor CG and moment of inertia. Although these topics are very simple and you can read it, but just for the sake of completing your syllabus, I will complete these topics also. Okay, so guys, I tried to explain these things simply to you, even though these are not so simple. Actually these are complex, and I know that in BTech courses we are not being taught these things, and even teachers are not much aware about these topics. So that's why I have covered all these things: traction theory, and then weight transfer, weight distribution, then tractor stability. Okay guys, I hope that now you guys are able to understand all these things. So just try to understand the concept behind all these things. Once you understood the concept, nobody is going to stop you. Okay, so thank you guys, thank you for watching. Okay, and please subscribe the channel, spread the word, and like the video if you really like it and enjoy it. Okay guys, thank you very much.